Hello, my name is Erdem and today I'll be presenting my review on energy-aware operating system design for mobile devices. Smartphones are way more powerful now, but batteries haven't really kept pace. That's why the software that runs our phones is super important for keeping them running smoothly, not too hot, and for as long as possible. I'm going to talk about how phone software has gotten better at managing power, from the first smartphones to today's phones that use fancy tech like machine learning and AI to schedule tasks. I also look at how Android and iPhones do things differently and point out what's new in Android 15. When we talk about mobile devices, everything depends on the battery. And while CPUs, NPUs, modems, and displays have become much stronger, battery chemistry only improves a few percent each year. Because of this limitation, the operating system has the responsibility to manage where energy is used, when hardware is active, and how background tasks behave. Over the years, OS developers introduced smart scheduling models, better background task control, and predictive energy management using machine learning. So the key idea here is that an efficient OS directly affects battery life, performance, and how hot the device becomes. Without OS level optimization, even a large battery would drain quickly. Uh, Modern phones do a lot more than older devices. They run AI models, high refresh rate displays, 4K video recording, online gaming, and camera processing pipelines. All of these tasks consume energy extremely fast. Without an energy aware OS, the CPU and GPU would stay active even when they don't need to be uh, like that. So that leads to quickly battery drain and overheating, which results in thermal throttling, meaning that the device slows down to protect itself. So an energy-aware OS is designed to prevent unnecessary hardware activity, avoid overheating, and extend the lifespan of the battery. This is why companies invest heavily into OS-level power management instead of relying only on hardware improvements. Energy management has developed a lot over the last 2 decades. In 2007 and in 2008, the first iPhone and Android phones had very simple power control. CPUs had fixed frequencies, background apps were not heavily restricted, and multitasking was extremely limited. Then came the introduction of DVFS, dynamic voltage and frequency scaling, which allows the CPU to adjust its frequency depending on the workload. This alone saved a significant amount of energy. Later, systems became smart about display energy. Today's devices have LTPO screens that can drop from 120 all the way to 1 to save battery. And in recent years, machine learning has entered power management. OSs now try to predict user behavior, for example, which apps you're likely to use or avoid, and optimize their background activity accordingly. So overall, the evolution moved from simple reactive mechanisms to complex predictive and ML-based techniques. Android uses a layered and highly modular approach to energy management. The OS restricts background tasks, controls CPU placement, and tracks app behavior over time. One major feature is doze mode, which activates when the device is idle. It significantly reduces CPU wake-ups, network access, and background tasks, extending idle battery life by up to 30%. Another important component is the energy-aware scheduler. It first tries to put tasks on the CPU cores that uses the least energy, such as the little cores. It only switches to the more powerful cores when it has to. Android also includes adaptive battery, which uses machine learning to detect which apps you rarely use and limits their background accesses. All of these features together will, with thermal management systems, help Android phones stay efficient, especially during long-term use. iOS follows a different philosophy because Apple controls both hardware and software. They can integrate energy management very deeply. One of the biggest differences is how aggressively iOS suspends background apps. As soon as an app is not on screen, the system pauses it completely unless it has special permissions like music playback or location tracking. iOS also works closely with Apple Silicon, so stuff like the display controller, GPU, CPU, and neural engine all share the same power management. This helps iOS devices stay fast without draining the battery too quickly. Another strength of iOS is the thermal management. The system constantly monitors the device temperature and adjusts performance before overheating occurs. This helps avoid sudden frame drops or shutdowns during gaming and video recording. One of the most interesting parts of my research was looking at the transition from Android 14 to Android 15. Android 15 brings several major improvements to how the system handles energy. First, the Energy HAL 3.0 makes it easier for hardware and software to share energy information. That way, scheduling can be more accurate no matter what device you're using. Second, Android 15 uses per app energy budgets. Apps that consume too much energy get restricted automatically based on real-time classification by machine learning models. Uh, Third, Android 15 introduces hybrid CPU-NPU scheduling. AI tasks are automatically pushed to the most efficient hardware component, similar to Apple's neural engine scheduling. And finally, Android 15 improves thermal prediction, meaning the system tries to prevent overheating before it happens, not after. Overall, these changes bring Android closer to Apple level hardware-software integration. Uh, and So when it comes to mobile devices, making sure the operating system is uh, energy smart is super important. Batteries aren't improving all that fast, but our devices keep needing more and more power each year. Operating systems are now in charge of managing everything. The processor, graphics, memory, sensors, modem, and screen. To make sure your phone runs smoothly without draining the battery too quickly. Uh, yeah. So Android is all about being flexible, open, and using machine learning to guess what you'll do next, while iOS prefers to keep everything working closely together and keeps a tight rein on what apps can do in the background. Both way work well, but they focus on what's most important to each system. Uh, in the future, expect mobile systems to depend even more on machine learning, safe AI chips predicting when you'll need power, and energy saving 6G networks. These are the things that will shape how we get the most out of our phones in the years to come. So, thank you for your attention and listening.